This video will cover Chapter 2 from Edexcel IAL's P2. The main emphasis of this chapter will be on the coordinate geometry of circles, but we'll learn other stuff along the way as well. We'll begin by learning about midpoints and perpendicular bisectors of straight lines. For this, you might need some basic knowledge on lines, but it won't be much. So basically, if I have a graph over here, and I'm given a line segment, so basically a finite line between 2 points. If I want to find the exact midpoint of this, I'll need to know, so this is y-axis and x-axis. I'll need to know the x and y coordinates of this first point. So this point 1, this is point 2. The x and y coordinates of, basically the coordinates of P1 is x1 and y1, and for P2 it's x2 and y2. If I have it in this form, the midpoint, I'll call it M, will be given by this formula. So the x coordinate will be x1 plus x2 divided by 2, basically the average of the x coordinates of point 1 and 2. And the y coordinate will be similarly y1 plus y2 divided by 2. That's all you need to know for the midpoint. So this is what a perpendicular bisector is. So if I solve an example question from this topic, basically if I want to find the midpoint of this line, which has the line segment which has these endpoints, so the midpoint of the line AB, line segment AB, will be x1, which is this, and x2, which is this. I'll add them up, divided by 2. The y coordinate will be 4 plus 7 divided by 2. So this is the midpoint of the line segment AB. So if you have already done coordinate geometry for straight lines, you can find the equation of the perpendicular bisector like this as well. So gradient, I'll do this assuming you have you have learned about the coordinate geometry of straight lines. If not, do that first. So gradient of AB will be 4 minus 7, which is, what I'll do, this is, I'll consider this x1, this is x2, y1 and y2. The formula for the gradient of a straight line segment is y2 minus y1 divided by x2 minus x1. So if I apply the formula over here, I'll get 7 minus 4, and in the denominator I'll get 4 minus 3, which would be 3. So the gradient of the perpendicular bisector will be minus 1 divided by 3. So this is the gradient of the perpendicular bisector, and we know that it passes through this point M. The coordinate M is 3.5, 5.5. So this is the point that the perpendicular bisector runs through. So the equation of the perpendicular bisector will be y minus 5.5 equals to m x minus 3.5. This is how you could find the equation of the perpendicular bisector. So this is the part about straight lines. Now we'll move on to circles. So this is the main part. We are moving on to it right now. So well, if we think about it, suppose we are given a circle on the graph and I'm given the diameter. So this is A, this is B, this is the diameter. If I have the diameter, I can easily find the center of the circle. It would be the midpoint of the line segment AB. The center is the midpoint of the diameter. So this knowledge of finding the midpoint will be useful. So if I have A, which is 1,3, B, which is 5,4. So the center of the circle will have coordinates 1 plus 5 by 2, 3 plus 4 by 2. So the center of the circle has coordinates 3, 7 by 2. I'll just change it to 3.5. So this is the coordinate of the center. Now if I want to find the radius of the circle, I can do it in two ways. I can do it without finding the center at first, but since I have the center, I can just find the distance between C and B or C and A. So if I want to find the distance of the line segment CA, or the length of the line segment, I'll do this. So root over the difference of the x coordinates, which is 3 minus 1 squared, plus the difference of the y coordinates of C and A, which is 3.5 minus 3 squared. This is the radius, which is root 17 by 2. Now for any arbitrary circle, so for any circle with a center A comma B, I can take any point on its circumference. So any point, any arbitrary point x, y, and this is the radius. So to find the radius, what I'll do is root over the difference in x coordinates, so x minus a squared, plus the difference in y coordinates, so y minus b squared. If I square both sides, I can cancel out the square root, so I'll get x minus a whole square plus y minus b whole squared equals to r squared. This is the general form of the equation of a circle, and this is how it comes from. This is where it comes from. It can come in another form, which is the extended form. So if I complete this, if I break this whole square over here, I'll get x square minus 2ax plus a square plus y square minus 2by plus b square minus r square equals to 0. I'll get x square plus y square minus 2ax minus 2by plus this constant over here, a square plus b square minus r square. So this a over here is the x coordinate of the center, and this b over here is the y coordinate of the center. So this one is the more common out of the two. This is rare, but you might still approach this. So if you approach anything in this form, you can easily find out without having to bother completing the squares to get to this form again. So in both of these forms, A is the x coordinate of the center of the circle, B is the y coordinate of the center, while r is the radius. Oh, and another thing to note, if you get anything in this form, you can easily find out the radius as well. So you might get a form like this, x squared plus y squared plus, I suppose, fx plus gy plus this constant over here equals to 0. Now you know that this constant is a square plus b square minus r square. So r square is c minus a square minus b square. Oh, sorry. It's a square plus b square minus c. If I want to find r, I'll just square root the right. And we also can find out a and b from here. So minus 2a is f. So f is equals to minus 2a. Therefore, a is equals to minus f by 2. And g is equals to minus 2b. So b is equals to minus g by 2. So we can replace the forms of a and b over here as well. So this will be minus f by 2 square minus plus minus g by 2 square minus c. It might seem too complicated right now, but if you solve a math, this will get easier. So I'll do just that. So for example, the equation of a circle is given x square plus y square equals to 4x plus 16y plus 3. So if I rearrange this, I'll get x square plus y square minus 4x minus 16y minus 3 equals to 0. Now I have minus 4 as f over here. So the center of x coordinate of the center will be minus 4 by 2, which is 2. B will be minus 16 by 2, which is 8. Here f is minus 4, g is minus 16, and c is minus 3. Now if I want to find the radius, it will be the square root of a square plus b square. So 2 square plus 8 square minus c, which is minus 3. So the radius will be root 71 units. Now there's a common type of question where we are given a random point. So we are given a random point PQ and we are asked to find if it's inside the circle. So if I want to find it, I'll use this circle as an example. So, and a random point, I'll choose 3 and 10. I want to find if this point is inside the circle or not. There are two approaches. One is finding the distance from the center and comparing it to the radius. I know the midpoint of this circle is 2, 8, and I know the radius is root 71 units, which is root 71 is around 8.426. Now I need to find the distance between the center C and this point. I'll name it P. So the distance CP will be root over 3 minus 2 square plus 10 minus 8 square. So this distance is root 5, which is approximately 2.236. This is less than the radius. Since the distance is less than the radius, this point must be inside the circle. So this is the first approach. The other would be to use the equation of the circle itself. So now moving to approach 2. I know the equation, I know this form, but since I already know the center, I'll convert it into the more common form. By using this, I can reduce the amount of information I need to use. So I know the A over here is 2, B is 8, and this is root 71 squared. Now I want to find if the point 3, 10 is inside the circle or not. So I'll put 3 instead of x and 10 instead of y. So I'll get 3 minus 2 square. So this is the left hand side. The left hand side is 3 minus 2 whole square plus 10 minus 8 whole square. If I calculate this, I'll get 5. On the other hand, the right hand side is 71. Since left hand side is less than right hand side, P is inside the circle. Now if P was outside the circle, the left hand side would be greater. I can show you another example of this. So instead of 310, if I had a point, suppose 100, 100, this is surely outside this circle. I'll get 100 minus 2 square plus 100 minus 8 square. I'd get 18,068. In this case, the left hand side is more than the right hand side. In this case, P is outside the circle. You could have also solved this problem while using this form, but I'd encourage you to convert it into this form and then do it, so you'll have less chances of making an error. And further information, if the left hand side and right hand side are equal, it means that point P lies on the circumference. So if left hand side and right hand side are equal, P is somewhere on the circumference of the circle, anywhere over here. So graphically, these are the cases. If the left hand side is smaller, P is inside the circle. If the left hand side is bigger, P is outside the circle. And if left hand side and right hand side are equal, you'll get this where P is on the circumference. Now we'll be moving on to tangents and chords. So what's a tangent? A tangent is a line that touches the circle at one point only. So we'll see that it's a line, so it would mean that it's infinite, so it has no endpoints. So if I have a circle over here with a center C, and this will be the tangent. Notice how it only touches it at one point. This is the special case about it. Now there's a very important property of a tangent, and that's this. So if you draw the radius over here up to the point where the tangent is touching the circle, the radius, so this line segment over here from the center to this point, name it P, this will be perpendicular to each other. This is one important property. The other thing is chords. So a chord is a line segment joining 2 points on the circle's circumference. Notice that it's a line segment this time, so it is finite. So if I have a circle over here and 2 randomly chosen points, and then I join it, this is the chord over here. Now the property with the chord is that if I draw its perpendicular bisector, the center of the circle will fall on it. And remember that the perpendicular bisector is a line. I mean, it isn't important, but it's still better to know. Now for tangents, at any point of a circle, there will be a tangent. So any randomly chosen point on a circle will have a tangent, and we can find the equation of it. So if I have a question over here, So if I have this question over here, this is an edited form of the question from the Edexcel's book. So I have this question over here and I need to find the equation of the tangent. To do this, let me use the property that the tangent will be perpendicular to the radius. So if I sketch a random circle and the tangent over here. So first I need to find the center, which I already know the center is -9, 1. This point over here, I also know it. This point is -7, -6. And I know that this is a right angle. I can find the gradient of the line segment PC. So if I find the gradient of this, -6 -1 divided by -7 minus -9. The gradient of this line over here is -7/2 or -3.5. This is the gradient of the line segment PC. So the gradient of the tangent, I'll just denote it as T, will be -1 divided by -3.5, which is 2/7. I know the gradient of this line now, and I also know that it passes to -7, -6, so I can just find the equation. So the equation will be y minus y1, which is -6 in this case, equals to m, which is 2/7, x minus x1, which is -7. So I get y equals to 2/7 x plus 2f plus 6 on this, so -6. Y is equals to 2/7 x plus, sorry, -4. This is the equation of the tangent. Now the question might have been asked in this way as well. So instead of trying to find the tangent, we are given this equation and now we have to show that it's the tangent. The way to do that is we have this equation over here with y in terms of x. I'll put this y over here and then we'll proceed. So if I do this, I'll get x plus 9 whole square plus, instead of y, I'll have 2/7 x minus 4 minus 1 whole square equals to 53. I'll expand this. Before that, I'll fix this. So 2/7 x minus 5 squared. Now I'll expand the brackets. I'll get x squared plus 2 times x times 9 plus 9 squared plus 2/7 x whole squared minus 2 times 2/7 x times 5 plus 5 squared minus 53 equals to 0. I'll have x squared plus 18x plus 81 plus 4/49x squared minus 20/7x plus 25 minus 53, which would be minus 28. I'll put the terms together. So x squared plus 4/49x squared plus 18x minus 20/7x. I have plus 81 minus 28, which is 53. To make this nicer, I can take 1/49 out. I'll get 49x square plus 4x square plus 18 times 49, which is 882x minus 20/7 into 49, which is minus 140x plus 53 times 49, which is 2597. You didn't need to do this. I'm just doing it to make this nicer. So I have this equation over here, which will be 53x squared plus 742x plus 2597. Now you have two approaches you can take. One of them will be to find the determinant. So b square minus 4ac, which in this case would be 742 square minus 4 times 53 times 2597. This would be 0. Since b square minus 4ac is equals to 0, this means that there is one point of intersection. And if the line has one point of intersection with the circle, it must be the tangent. This is the property of the tangent. So this is how we show. The other approach would be to just factorize this. So if I factorize this quadratic over here, I can take 53 out, x squared plus 14x plus 49 equals to 0. We can just show that this, I can remove the 53 over here, and then I can show that this is just x plus 7 whole square equals to 0. So x equals to 7, x equals to minus 7 is the only answer, or the only intersection point. This is how I show it. So the approach is the same. We have to show that there is only one point of intersection between the line and the circle, but we can either do it by factorizing it or by finding out the discriminant and showing that it's 0. Now coming on to chords, their property can be used to find the center of the circle easily. So if I have a circle over here and I don't know the center, but I'm given 3 points on it. So A, B, and C. Then I can get the chords. So the chord AB and BC. So I have two chords AB and BC. If I draw the first perpendicular bisector, this is the perpendicular bisector to AB. I'll just move it a bit. So this looks right enough. Okay. So I know that the center will lie on this line over here. And if I do the same for BC, so I'll draw the perpendicular bisector to BC. Guess what happens? They intersect at a single point. Since I know that the center will be anywhere on this first blue line, and also on any point on the second blue line, to satisfy the property for both perpendicular bisector, the center must be at the intersection point. So this is the center of the circle. So this is how you can find the center of the circle, given that you have 3 points on the circle. So if I am given 3 points on the circle, so x1, y1, x2, y2, x3 and y3. At first I'll find the equations of the chords. So this line segment chord AB will fall on the line. I don't even need to know the equation, I just need the gradient. So the gradient of this chord will be y2 minus y1 divided by x2 minus x1. The gradient of chord BC will be y3 minus y2 divided by x3 minus x2. From this I can find the gradient of the perpendicular bisector of each, which is basically minus 1 by the gradient of the chords. Now I know the gradients of the perpendicular bisector. I need to find the midpoints to find the equation. So this is midpoint 1, midpoint 2. Midpoint 1 will have this coordinate x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. The second midpoint, or basically the midpoint of BC, would be x2 plus x3 divided by 2, comma y2 plus y3 divided by 2. From this you can find the equation of this perpendicular bisector. So perpendicular bisector 1 and perpendicular bisector 2, you can find the equations of both of this, since you know a point on both of them and their gradients as well. And then you can just equate y equals to y, put the equations of PB1 and PB2, then you'll get the point of intersection between them. Do note that you need basic knowledge in the coordinate geometry of lines before you approach this. Otherwise you... Now I want you to pause the video and try to solve this question. I'll show you the detailed solution in 3, 2, 1. There's another property of triangles in circles that comes up in this question a little, and it's the fact that so if I have this angle over here, so this is the diameter. So if I have 3 points A, B and C, and suppose AC is the diameter, if I draw the chords AB and BC, they will be at 90 degrees to each other. Or if I think only about this part, this is a semicircle, so the angle subtended at the circumference for a semicircle will always be at 90 degree. Conversely, we can also think of it as the other way. So if I know that this is a right angle, I'll know that this is the diameter. So if I know that two chords are at 90 degrees to each other, the other chord must be the diameter itself. So this is the property. I was talking about the previous question because in this case the gradients of the perpendicular bisector are minus 1 by 9 and 9. Minus 1 by 9 and 9. So they are at 90 degrees to each other. I don't need to go that far as well. So the gradient of the chord AB is 9, the gradient of the chord BC is minus 1 by 9. So these two, this and this, are perpendicular to each other. So we have a case like this. So yeah, this is 90 degree. So this must be the diameter itself, and the center point of the diameter is the center. We could have solved it in that manner as well, but I solved it in the broader manner. The way in which we would have solved if we didn't know this fact over here beforehand. Now we know that we can also solve this question using this fact. And that's it for this video.